Well, welcome to the Mentored Engineer. I'm once again sitting down with Clay Counts, and we're going to talk about terms used in the IoT industry. Clay, I wanted to do a video on just terms used in this industry, and we'll define those. Just because there's a lot of times that people get lost in the terminology and nobody ever explains it, and they have to be like, what do you say, and try to figure it out. So let's talk about some of the terms as far as you mentioned digital and analog connectivity and the one wire.
Yeah, absolutely.
Can you explain those?
Yeah, so I'll start with digital. Digital is a type of, we use relays, read relays, and Form C is what we typically use here. Digital is either an on or off signal. So you either have on or off, it's not a variance. So use that for monitoring things and controlling things like doors, lights on and off, level to a certain point. So it hits 4 feet, 5 feet, whatever your level is set at. So that's how digital would work. Analog is a variance. So you think of something like pressure. Pressure is not necessarily either on or off. You either have 1 pound per foot, or it goes 10, 15, whatever it may be. Temperature is another analog sensor or analog measurement. So analog measures variances. Well, the one wire we use is it's a little bit different. It's an architecture form of sensors that gives simple plug-and-play connectivity to users. So in our situation, we use one wire to measure temperature. But there's a whole number of one-wire sensors. You have pressure, humidity, voltage. There's a whole number of one-wire sensors in that arena.
Okay. Go into one wire just a little bit more.
Yeah.
So if there's one wire, how do you measure 10 different temperatures?
Absolutely. So this is the beauty of one wire, and it's just the way the architecture is designed. If you ever plugged in a phone into a phone jack using the RJ11, RJ45 connectors, you can plug in a one-wire sensor. And they use have a very low power pool, and the way the wiring is designed, you can run up to 10 sensors off of one-wire connection off of our 370 device. So plugs in, no additional power supply required. It pulls it from the device, and you can run as many as you want off of there, up to 10 off of there. You can daisy chain them. There's a whole number of ways you can get sensors out from there. Neat thing too, as well with one wire, is these temperature sensors have a unique identifier, so you can tell which one's which. So if you plug it in, set it up on our device, you can know that that's the freezer, that's temperature sensor 1. And if you unplug it, plug something different in, that's going to have a different ID. So if you unplug it, leave it off for a few days, plug it back in, our device is going to recognize it right away and know which one it is.
Right. So this is sending some sort of serial type communication through that one wire?
Yeah. So it sends a communication back from the temperature sensor, which is a little middle node that you put in your area that you want to monitor. Sends that back to our device, and our device just sends that data to the cloud, which interprets that data.
So as far as analog inputs are concerned, some things you want to know is the range of the voltage that the device can accept, and what the bit rate is on that as well. So can you shed some light on those?
Absolutely. So your device may have a range of, say, 0 to 10 volts and a specified bit rate. That you're going to need to know that and understand that so you can interpret your data on the back end. Because if you don't have the correct voltage matched up with what you want your pressure to read, then you're going to get data that's going to be either incorrect or unable to read in those type of situations. So that's kind of how analog works. Like I said, with digital, you're either on or off. Analog's a little bit more technical in the fact that you got to understand modes of communication between your device and the sensor.
So one other thing is when you're looking at devices that read analog voltages, you want to look at how many bits it has per channel. This is the number of divisions in between the 0 and 10 volts that a sensor can have. If I have a 0 to 10 volt range and I have a 4-bit channel, I'm going to get 2 to the 4th, which is 16 segments in between 0 volts and 10 volts. Well, that's probably not enough. Most devices probably have over 10 volts. Some of them have 16, which would be fairly on the high end. So the number of bits you have it's really going to increase your resolution. And once again, to find out how many lines you have or how many points you have in between, it's just 2 to the bit rate. So Clay, can you tell me a little bit more about terminology used to transmitting data to the cloud?
Yeah, sure. So there are a number of different ways that people do this. My expertise is in obviously how Sealevel does that. With it being either via cellular or Wi-Fi, we use MQTT as a communications method. And MQTT, basically what it is, it's a small data packet that's easily transferred via cellular. So it's great for intermittent connectivity. So if you lose cell service or it degrades, you can still send these MQTT packets. And the device is able to store this data and wait until there is connectivity to send it. So it's wonderful, nice little small pieces of data that it can send to the cloud, and then the cloud does the interpretation on the back end.
Right. So we mentioned in a previous video what a Form C relay is. So I'm assuming that if there's a Form C, there's got to be a Form A and B?
Well, actually, so we have a Form A or a common relay is what some people call it, also a read relay. And the way these two devices are just a different style of working, and I'll show you a read relay. You have 2 nodes, and when their voltage is applied, they connect. Whereas a Form C is like a gate, so it's either normally open or normally closed. So Form C is better for higher voltage situations if you need a higher load for actuating your device, whereas a read relay is great for lower voltage situations. Our device right here, the 370, has Form C relays on it, but we do have other devices that have read relays. So it's really based on your application-specific needs as to which type of relay you would need.
All right. That concludes our video today. We thank you for watching, and please subscribe to The Mentored Engineer. Hi, this is Corey with The Mentored Engineer. We really appreciate you watching this video, and we want to reach out and just say that we are now offering Skype consults for your projects. So if you need help getting a project off the ground or you got stuck at a certain point, reach out to us and we can help you. To do this, go to the homepage of the website, mentoredengineer.com, and click the Skype consult button, and we can get in contact and start working on helping you through your project.